This is going to be fun. We're going to talk about Qualcomm's 1.7 million lines of code. And documentation and text. Maybe not exactly all code, but you know, you'll see. So who am I? I think I know most people here, but if you don't know who I am, I'm Stephen Boyd. I've been a kernel developer at Qualcomm for the last 6 years. I've been maintaining the Common Clock framework, co-maintaining, and plus I do some OPP reviewing on the mailing list with Varesh. Everything I'm going to be talking about here is code that's on Code Aurora. You can go right here to this link and you can look at everything I'm talking about. You can even do git diff just like I have done on this 3.18 kernel, just for reference. So this is the meat of the talk. I'm just going to be talking about this diff here. And the tree is based on LSK, so great job, Linaro. You've made it's based on 3.18, and this contains the Android common tree inside of it. So the Qualcomm branch is just a merge of this LSK and then all the Qualcomm code on top. As you can see in this diff, the diff is quite large. It's 1.7 million lines of additions. The number of patches just authored by people in Qualcomm, which would be author Code Aurora, is 12,000. That's the last time I checked. That's insane because this started in May, and May to when I did this analysis was 10 months, which means that's approximately 120 patches a month, or 40 patches a day, and this doesn't include the merges. So somehow there's 40 patches going in every single day, 24/7 throughout the entire year. Yeah. So also, just the slides want to point out that LSK is much tinier compared to whatever has been added by Qualcomm. That is actually 1 or 10% of it, I guess I would say, right? Number of changes, and the number of lines is nowhere near close to what's going on there.
I think like half of that is Android.
Yeah, I mean, I don't know how much. I didn't do the analysis of Android versus Linaro, but yeah, that's probably half, right? Or I think Android's getting smaller though.
It was 30 or 40K last time I looked.
Okay. So if you do the diff stat, which cuts off at 3% by default, so I didn't really care to show anything below 3%. You see this nice cumulative diff stat we have. The first thing that jumps out at me is that 67% of the changes are drivers, which I guess is a good sign because Qualcomm is a hardware company and should be making changes in drivers. The other thing that's kind of interesting to me is that 10% of the diff is DTS stuff and documentation, which is huge. That's 170,000 lines of code is device tree, which is really gigantic. The other thing that's interesting is clock is really large. I work on a clock framework upstream, but somehow we have 3% of the changes are in driver's clock, which is scary. And also, I mean, the GPU is big, and that's kind of like a dead end, so we're never going to upstream that. So all that code there is also pretty large. Yeah.
So is the DT documentation, is that backports of...
Do you want a microphone so it gets recorded?
Is the DT documentation backports of reviewed bindings, or are you actually documenting your vendor bindings?
Yeah, so all the vendor bindings are documented, and inside the company, that's it's done in a I don't know how to say it, but it's done in a way that causes everybody to make lots of documentation. So yeah, it's not, most of it is not upstream. If that's what you're asking. Okay. So other things that are kind of large here is that if you see like the media changes, drivers media, that's pretty big, and that's a bunch of camera stuff and video encoders, and there's also some radio changes in there and some broadcasting stuff. I don't understand any of this stuff, but it's in there. We have, there's another question?
Yeah, so you're probably going to come to that anyway, but sound is the biggest driver subsystem that you have?
What's the biggest driver?
The largest set of driver updates is for sound. That's bigger than video or media.
Yeah, I was going to get there.
Yeah.
So sound is 10%. From what I can tell, sound is a bunch of codec drivers, and the DSP driver is gigantic. I'm not exactly sure why the DSP driver is so big, but it's pretty big. Actually, I don't even have a slide on that. Sorry.
Does it have a compiler in it?
Is there a compiler
In it?
Probably, and an email client as well, right?
Abstraction layers are really important.
Yeah. So I mean, I actually ran out of time and never looked at the sound. Maybe next month I can look at sound, but it's a nightmare, and it's a bunch of code in there. I don't understand why they even have it.
Yeah, there's a lot of abstraction layers.
There's a lot of abstraction layers in that in the DSP code, and I'm sure many of them do something useful. But there's a lot of them, and they seem to require a lot of code each.
Yeah, every single chip seems to generate a gigantic file.
Yeah. So the codec drivers, that's normal. That's standard. That's expected. It's basically just a register list.
Right. So it's big.
Yeah, but that's expected. That's the problem space. But the DSP, I suspect, could be written with less code.
Yeah. The DSP is the same size as all these codec combined, right? So that's
kind
of scary. So going back to my list, I was just going through alphabetically. You jumped to the end, aren't you? But it's okay. There's also this thing in drivers platform that you see. It's called MSMIPA. That's this interesting piece of hardware which lets you accelerate packet transfers from the modem to the networking stack inside Linux. That has been copied 3 times and put into the same directories because, versions change, and so you must copy. And so that driver just becomes really big, and almost nothing is different between the 3 versions. Probably, a couple thousand lines of code, which I guess is still significant, but it's nothing compared to the size of the driver in general. Also inside drivers platform is some other stuff. I'm going to go through all this later, but I'm just going to give the overview.
That one shouldn't even be in drivers platform. Nothing
drivers
should be in drivers platform, right?
Drivers platform, I think, so people keep them there sometimes, and then they've moved them to drivers SOC depending on what the team decides to do what when. So I know drivers platform is drivers platform is gone, right? But it's dying.
No, it's used for platforms, but it's not used for SOC specific stuff.
Yeah.
So we have drivers platform Chrome, we have drivers platform OLPC. Those are platforms that each use several SOC families.
I don't know why you put a networking driver or a networking acceleration driver inside there, though.
Because the network maintainer does not take network acceleration drivers.
That's true. So you just put it somewhere. Yeah. So beyond that, there's drivers power, which is pretty big too, 3%. That's various power things like all this CPU idle code and suspend code, and there's also this charger driver in there, and there's a battery monitoring driver in there. All that stuff is hanging out in this directory. Then drivers SOC is full of a bunch of debug code, IPC mechanisms, all the SOC things that we'd have no home for. And then if you see the frame buffer driver is gigantic too. That's drivers video, MSM, MDSS. That's 9%. I don't go into analysis on that, but that's just making a note. That's pretty big. Probably more register lists again.
When I haven't looked at 318 yet. At least as of 310, they had I think at least 2 or 3 implementations each of basically the same HDMI block and same PSI block.
It's more copy paste.
It's tons and tons of copy paste.
Yeah, copy paste is a common thing, sadly.
And how far are you from being able to use KMS? I know it's been discussed that you might be using more KMS internally. Or do you know about that?
I don't know.
Okay.
Sorry. I've heard rumor that it might happen, and then the next day I hear it might not happen, so I'm not sure. Okay. So I'm going to kind of dig down into some of these little subdirectories. As you saw in the previous slide, 9% of it was Arch something. And I'll make a note here that everything in the 318 tree is an Arch ARM boot DTS. They don't do anything on ARM64, even though the ARM64 DTS files are there. They have there's a symlink or something that's being used. So that makes it easier, at least for me to do the diff subtraction here is to show you that 2.7% of this is not DTS code or DTS changes. So it's still kind of large. So I picked out the top 3 files in here. So 318, the DMA mapping file has a hacked port of DMA from ARM32 into ARM64, mostly to get the SMMU ops, because at the time it seemed like it was not back ported, or it was not upstreamed yet. So, and there was nothing on the list, I think, or something like this, and so they just kind of did something to make it work. There's also some additions into the DMA API, like they added no kernel mapping support into there for ARM64. That's to do some memory saving things, and also to avoid mapping some protected memories that we have. There's also a attribute for strongly ordered memory. This is for the execute.
We already had 3 of them.
Yeah, they've added 3.
We have like 3 different people added at DMA attributes for
Yeah.
strongly ordered memory, and then you have another one.
I'm sure. There's also a executable mapping attribute added. This is being used to give the DSP memory from the kernel. So it seems like we allocate some DMA region and then we map it into the SMMU for the DSP as executable. This has been added to the DMA APIs as well. There's this code for DMA remap and DMA unremap. I sent this on a list this week, but this is to move a window of DMA across a DMA allocation area. This is for low mem savings, or to save vmalloc space.
Can you just repeat that? I didn't get that at all.
There's an API here called DMA remap and DMA unremap, which lets you map a window or map a chunk at a time into a DMA region that's been allocated. So they allocate the DMA region with this no kernel mapping, and then you slide the window across to put it into the kernel's address space, so that you can then write things into the DMA region a chunk at a time.
So it stays mapped in the MMU, and then
It could be, but there's no SMMU. There's no MMU at all. Is that what you're asking, or are you saying the kernel or the CPU's MMU? Which one? When you allocate with no kernel mapping, there's nothing in the MMU. There's no page tables.
okay.
Right. There's sometimes.
Yeah.
And then you do this DMA remap API to put it into the page tables, so that you can write to it, so that you can then unmap it, so that you don't run out of memory.
On the 64, like you don't
Yeah,
run
this
out
is
of
also
virtual
done on
memory
the
space on the
64.
64-bit.
This is done for the 32-bit, and then it was copied into the 64-bit version, because make code the same.
Okay.
Yeah. After that, there's also another attribute, skip zeroing, which is used in the DMA allocation so that you don't do the zeroing part when you allocate a big chunk of memory. And that's also used to let you map these regions of memory without blowing away like a reserved region. You may want to map it into your page tables and then not overwrite something that was there. So there's these chunks of memory that are reserved and they might have information in them, and they're allocated with DMA allocation because that's the only method to bring memory into the system that's not mapped typically. Okay. After that, the perf code is big, and that's because it has some hot plug stuff and CPU power saving or context saving features. I saw that someone sent a patch to the list last week for this. This is to save the counters across low power modes, but that's a bunch of code in there. Just a couple of patches.
And that's platform independent, right?
Yeah, it's platform independent. That's just code to save restore context over CPUs losing context for their counters. There's also the cryo-specific PMU support, but that's not actually in this file. That got moved to drivers SOC for some reason, but that's hooked into this file, so they have some weird calls from there.
Yeah. So that needs to be moved back.
Yeah, that needs to be moved. I lost my mouse somehow. I don't know how to
Okay.
scroll down.
Okay.
I can't see most of my notes, but it's okay. Oh, here. I think I got it. There's also the last one in the MMU code. There's some debugging features Both of these are going to go away from what I can tell after some things are upstream, but there's read-only kernel text that's been added in here, not the version upstream, some backported version. And there's also the support for Arch supports debug page alloc, but it has a totally different name, and I don't understand why it wasn't just done the other way. But those should both fall away, I hope, soon. Okay, going on, continue on, drivers clock, all right, that's 3%. This is Qualcomm's entire implementation of the clock API. They don't use common clock framework at all. They have not used it ever. Yeah, it makes me feel great.
So why do they even put it in that directory?
So it used to live in mock MSM, but on 64-bit there's no mock MSM, and so what do? You
Just put it somewhere.
just put it somewhere and you put it in the driver's clock.
Some vendors have added it. Yeah.
That's cool. Hey, maybe we're doing better, right? At Qualcomm, we didn't add it? I don't know.
Well, that sort of prompts the question, what kind of stuff from upstream has actually gone in? Like, for example, I think the core site stuff, they actually use that now because it was sort of written by Code Aurora in the first place. And,
Yeah.
and Björn's pin control stuff, that's also used, if I understand it correctly.
Uh-huh.
So some stuff did go in, but not the clocks.
Those are pretty much the only two things that I'm aware of.
Maybe we should think about how that we made that happen and do the same thing with the clocks.
Yeah. So yeah, the reason why it's not being used, from what I know, is that their implementation of this API does DVFS inside the clock framework. That's, I'm never going to do that. That's rejected. I'm rejecting myself, which is weird. But my plan for that is to use the OPP framework. I'm hoping that that will just work out and be fine. The other feature that's not that's not here yet is called clock handoff. We're doing that right now upstream. Hopefully have that resolved soon. That's to do this thing with the bootloader where the display is on out of the bootloader and it needs to stay on until drivers take control of their own resources. And when this clock is shared, half the time it kills the clock because some other driver turns off their clock at the end of their probe and causes the display to black or something. So that feature needs to be added. There's also stuff for, we need to do the coordinator rate changing. That's not being done yet either. This is so that we can do the next feature, which is Qualcomm does 1 lock per clock throughout the entire clock hierarchy. This is for scalability of independent CPU scaling. So if they have 1 lock for the entire subsystem, then set rate or CPU free transitions would be all synchronized, which would kill the entire feature that Qualcomm has of independent CPU or independent cluster scaling. So all those features are missing and are pretty much the only reason I'm told that we cannot migrate the code over to use the common clock framework. So most of these things are in progress. Just they need to be continued or accelerated so that this can be moved to. Continuing on, there's drivers regulator. I just pointed it out. It's not actually high enough for it to be bigger than 3%, but I wanted to cover it anyway. There's a bunch of code in here for DebugFS that will never be accepted and has already been rejected, and that's probably just going to hang around. I don't think they're going to get rid of it. Kind of highly doubt it. They also do the similar thing as clock handoff. They do handoff for regulators, what they call it proxy regulators. From what I can tell, every regulator has this feature enabled. Do you want a microphone? Pass you back somewhere.
So what is that feature?
So this feature is used to keep a regulator on. It's again for the display.
Oh, so it's cutting out. It's to cut out the power off at the end of late init call.
Not the late init. It's more like, for example, some other PHY shares the power supply pin with the display, and maybe like PCIe or something, right? PCIe driver probes first. It turns off its regulators at the end because it wants to save power at its probe, and that kills the power for the display, and the display goes black. This problem. So I think I think one solution may be to just use power domains and hope that that works.
Or
regulator.
yeah, or we could do something like defer all power offs until the end of late init call.
I mean, that's pretty much what this feature is doing. Right? It's
So
saying,
that
never
seems
turn anything off.
upstreamable. We'd then need a no, I really mean turn this off API call. For like SD cards and things where you really do actually need to turn the power off. Although regulator get exclusive probably already is that. But that seems upstreamable.
Okay. Well, it's good. Yeah, it's just sitting around. There's also changes in here to do voltage corners. This is where the regulator API is used to set voltages that are just 1, 2, 3, 4, 5 instead of actual volts, microvolts. This is we need to get rid of this. I don't know. I think we have a plan. My plan, hopefully, is to use runtime PM for that too, and hide it behind OPP framework, and never tell anybody about these corners. That's my plan. I hope it works, but we haven't done anything yet for that. There's also some stuff for sleep set versus active set in here. We've talked about this before too. Qualcomm has this feature where any regulator can pretty much be turned on or off, or any attribute for regulator can be changed based on the CPU state. So if the CPU is on, you can do some attribute, and if the CPU is off, it can be in another way. We need to plumb this through the entire regulator framework too, I think. I think we have some plans to do this.
Yeah, we have a design for it.
Yeah.
Oh, I should assign somebody to work on that, shouldn't I?
Yeah, you should. After that, a lot of the big code is there's 2 or 3 CPR drivers. This is Qualcomm's version of AVS. I think we need to remove all these drivers from here so that they don't count. They need to move to drivers power AVS and be rewritten, most likely, which will be fun. That, I mean, that's pretty much all the stuff in regulators, which is good. Next on to Iowamoo. So Iowamoo is kind of big, mostly because they've added a bunch of stuff on top of the ARM Iowamoo driver that's upstream. I guess that's kind of been upstreamed then for you. Yeah, so that's the problem, is that it has a bunch of code to not use the upstream binding, because I think at the time it was being used, there was no binding yet, or it was not fully decided.
So there was pretty early on an SMMU specific binding, which was pretty much broken, and then we added a generic binding for IMMUs, which is incompatible with that one. So do you have a third one then, or?
I think it's
one
the
of them?
first one.
Okay.
And I think they want to move to the next one, but they haven't done it.
Okay.
That's my understanding.
So there was a recent patch to move the SMMU to the generic binding.
As an alternative, right? So we don't break the existing one. Yeah.
Okay, and then so the other changes they've added is the power management. They've added a bunch of clocks, and then they have regulator calls for the power domains. That's another thing that needs to be done upstream. I haven't seen anything so far on that, but they need that, because if they don't have that, it doesn't even work. It's not on by default for some of these people, and
Yeah, this has traditionally been a problem with the IMMUs, because the initial design for the IMMUs was that they're on really early, and we expect them to always be there, but then the regulators come later.
yeah. So they have a bunch of hacks, I think, in the code, and they even do like makefile ordering hacks to make all this work right now. So it's really awesome stuff they got going on. After that, there's page table optimizations they've added. They have some optimization where they avoid flushing lines for each PTE when they populate them into their page tables for the SMMU. So like if it's slightly less than 2 megabytes and they're mapping a bunch of 4K pages in, they flush the entire page of mappings at one time. And this apparently has helped them meet their performance numbers. So they need to do some page table changes in this code, and that's helping them map.
That sounds reasonable.
Yeah. So I think they should just upstream this, but no one's.
There's lots of trade-offs that you can do with the IOPT flushing.
Right.
Some of which have security implications, some of them don't. Like, a typical trick is to not flush at all, and just keep adding a new virtual address for each mapping that you do. And if you hit the 4 GB limit, you flush them all. You start at the beginning.
Yeah.
Which has security implications because it means the device is able to still access pages that
Right.
we've tried to unmap before.
Okay, it's been a long time, but I think at some point we added there was a flag added to the map API. I'd asked for that. I haven't. What I wanted to do was, like for the GPU, I have well-defined points where I need the mappings to exist or not exist, but I could otherwise batch up mapping or unmapping a whole bunch of buffers at once. So you don't need to take the security risk to batch up updates. There's a point I was trying to make.
Yeah, there is the Iowamoo map SG API, I think, which was only like half implemented, and the part where you actually get the benefit of that was not ever implemented on ARM, I think, or something like this. So that needs to be just finished off, and no one's done it.
I can actually batch up multiple SG mappings or unmappings on the GPU side, so yeah.
Okay. There's also some hypervisor calls in this code that have been done for content protection. So they're actually communicating with the hypervisor to tell it about where the page tables are. This is scary to me, and I'm not sure how that's going to be upstream, but that's going to need to be done if anybody wants to play any secure content.
So usually what you do if you have a hypervisor is that you completely virtualize the MMU, and then you just have hypercalls. Instead of having an IMMU driver, you have a virtual IMMU driver that talks to the hypervisor.
Yeah, so apparently that didn't work, from what I can tell. And they still have to talk to the hypervisor. It is virtualized, but it didn't work. So that's going to be a problem, probably.
Do all of those chips have a hypervisor running?
Yes. No, all the latest ones.
Okay, all the B family?
No. Basically, just think 820, I guess, and that should be sufficient for...
Oh, sorry, what?
The Snapdragon 820 has a hypervisor.
Okay.
And so does Dragon Board 86. 410C has a hypervisor too. 410C has a hypervisor as well.
Okay.
So I don't even know what that number is. Can't keep track.
Q8016.
8016, yeah. So the other thing that's been added in here was apparently done by the GPU team, was to let them pretty much use the Iowamoo APIs to make a bunch of page tables for their per process page table stuff. And apparently that's also being used for the boot splash screen feature, because the display, when it boots up, the display needs to have page tables from the bootloader for the MMU. And so when you attach an IMMU, that just repoints the page tables, or TTBR gets repointed to nothing, and then the display goes black again. So the problem just keeps coming back like 3 times. I don't understand. But so they need some way to let them attach an IMMU without actually blowing away these page tables that are already there. So they have some hacks in the code to let them do this feature. It's just fun. And we'll have to figure something out for that. I'm not sure what to do. Continue on to drivers platform. This is just a bunch of assorted platform drivers that never got moved around and had no home. There's some random pivot drivers in here, which I don't understand why they're even in here. There's things like power on and coin cell. I don't know why they landed here. And also like a whole haptics drivers just hanging out in here.
How many of the overall code is actually being built?
I think all the code's being built, so Qualcomm periodically runs a program or a script to figure out what drivers are not built and then deletes them. So these things are all being used. Yeah. There's also a complete copy of the BAM DMA Engine code, but not DMA Engine driver. It's sitting in here, and it's being used by everything. So that's just a bunch of code that will never see the light of day upstream and needs to be deleted.
Say that again. Who's using this?
Every driver that's using this DMA Engine that Qualcomm has, called BAM, it uses this implementation of it instead of the upstream version.
But that's really hard to migrate, right?
Yeah, this is going to be pretty hard.
So how many drivers are there using this?
I don't know, 3 or 4, maybe more than that, 5, I think. Can't remember.
This has been, for the Samsung platforms, it's probably taken 5 years to get right, because they had the same problem, and with several attempts at doing a partial migration, and
Yeah.
it was a huge pain.
Might just have to bite the bullet one day, right, and just do it in one big blow. And
Yeah. So Marvell also had the same problem. I think for them it was a little easier. Maybe we should look at what Marvell did.
yeah.
Maybe their advantage was just that nobody uses their code.
Okay. There's also the bus scaling driver in here, which is used to scale the interconnects in the SoC. It's a pretty big driver that has its own directory, and it's just a bunch of code we have to figure out. I don't think we have a plan for that. We're just working on it slowly, or just starting to work on it. So hopefully that speeds up and we get that done. And then there's the IPA, which I talked about earlier. It's again one of the big things. And then there's
So what was that again?
IPA is the networking offloading for the modem. Okay. That's just a big driver that's hanging out in here too. And then there's this other thing called MHI, which is modem host interface. That's being used to communicate data and do controls with an off-chip modem over PCIe. And they're also doing things with this IPA hardware too, from this other driver. So they're all kind of intermingled. And this is all just networking things. Onto drivers USB. Most of the stuff that's in here is a bunch of PM changes to use runtime PM in places, and then there's a whole other implementation of the USB driver that's not upstream that they've added that's just sitting in here.
Which driver is this?
I'm sorry, I can't remember. Which, you mean like which PHY?
It's I meant which USB host implementation. Is it EHCI or
It's the
chip
EHCI.
idea? Or
It's the HCI. They've added a bunch of stuff to it for the DMA engine that's not DMA engine as well, because they can't use the DMA engine
EHCI doesn't
APIs.
use DMA engines. That doesn't
I
make
think they
any
must
sense.
have like attached it or something. I don't know.
Maybe it's not EHCI then? Maybe it's one of the others.
I'll have to
So
look at this.
MUSB can use the DMA engine?
No, they can't use DMA engine APIs at all, because the DMA driver is not written as DMA engine.
No, I mean MUSB you can use a number of different implementations of DMA engines. It doesn't actually all use DMA engine API.
Okay.
So some of the MUSB users have their own DMA engine that only talks to MUSB, so they don't have a driver for that. But I don't think you can use EHCI together with any DMA engine because it's its own DMA master already.
My understanding of BAM is that it just sits in front of, it's like a mini bus and it sits in front of any mastering of a device. So maybe they glued it in front. I'll have to look. I'll go check and let you know later. They also have a bunch of gadgets in here for Qualcomm specific tethering and diagnostics, and they even dump core site traces over this USB, so they've had just a bunch of random gadget drivers that need to be done. And then they've put a bunch of fixes into function FS for these race conditions they found, and I don't know why they haven't just upstreamed them, but those just need to go upstream, sounds like, which would be nice. I'm running out of time. So the next one is driver's power. this is a bunch of CPU idles and suspend code. I think Lena's and Linaro are already taking care of most of that stuff. Hopefully that just falls away. I'm hoping. I haven't seen yet what will happen. And then the other stuff that's in there is the charging code, which is just a big charger driver that's using the power supply framework to communicate with different drivers, which doesn't make any sense to me. So they added a bunch of properties, and they've added charging types for like wireless charging, and they're doing quick charging, and they want to know if they have a fuel gauge. And this is all being used to communicate through power supply framework, which is really scary. So hopefully they can change this design somehow.
Yeah, so we have some work ongoing to start dealing with bits of this currently for USB only, but the USB maintainers aren't being very cooperative, so it's kind of ground to a bit of a halt. But yeah, there's already some work going on that in Linaro, because it's a big issue for a lot of people.
Okay.
One issue there is that driver's power is in need of a subsystem maintainer who's or co-maintainer who's interested in complex charging hardware, because that was developed for laptop batteries, which are essentially autonomous systems, state machines that take care of everything for you and just report your figure so many %. Anything more advanced like that than that, there is not anyone maintaining the subsystem who actually is using that. They're just merging code and saying like, yeah, that looks nice, or looks okay, I can live with it. Somebody needs to actually provide the proper abstractions, and Intel did step in at one point and started doing some work, and then they fell off the planet.
Okay. Yeah, there's also this, they've added the battery calibration data library, which is used to load a bunch of stuff from device tree.
Yeah, all of this is science. I mean, there are people in academia that just work on that, and it's all in SI units and everything. It's just something that needs to be properly written and made a library around.
Okay. Finally, to driver's SOC QCOM. This is really huge. Also, it's 5% of 1.7. Wow. So there's a bunch of IPC mechanisms in here. They have a whole communication with trust zone in multiple ways. They also have communication between all the other processors in here. Those are pretty big pieces. There's also lots of random debugging code in here. They have all these error detection things. They have DDR testing code. They have cache numping code. I don't know if any of this stuff matters to upstream, but there's just a lot of it. There's also stuff to read CB15 registers right in user space, all of them. Just lets you dump things, it's just a bunch of crap. You gotta debug stuff. After that stuff, there's another little thing in here called event timer that's being used to schedule some HR timer on CPUs, so you wake up right before you have an interrupt that you know is gonna arrive. This is used for the display vsync interrupts, so right before it comes, you set a timer to wake you up so that you can meet your timelines, because apparently idle is not working too well. So they have this whole framework for just one driver, and that lives in here.
That sounds horrible.
Yeah, it's pretty bad, but it's there.
I said, upstream, we need to do a lot better on predictive wake-up. There's a lot of VBlank it's a sensible thing to do.
Exactly
you know when it comes, you want the CPU raring to go for the next frame.
And there's also this pill thing in here, which is used to boot the processors, the non-Linux ones. And this is a bunch of code, and now I think it's split across 3 or 4 files. It's getting pretty big. And that's also hanging out in this directory. We have a plan for that, it sounds like, right? So we'll work on that. So now just summary, I just have some short-term projects and some long-term projects. This is what I found maybe it could be some short-term projects. We can just upstream these function FS fixes that should just be done. And then we can add these no kernel mapping to M64. I sent the patch for this, and I've got some feedback, so I have to go work through that. I don't know if anybody actually even wants it.
So the no kernel mapping stuff seems fine.
Yeah.
Like having no kernel mapping at all, but then mapping it after the fact is the scary part that I don't think we should have.
Okay. Yeah, I'm working on that stuff right now, so we can talk about it later. It'll be fun. Also, the executable DMA mapping, I don't know if that's a short-term project, but it'd be a good project, I guess, for someone to work on.
I completely missed what that's actually good for.
That's used for to give memory to the DSP. So you map it and you steal some memory from Linux, and then you map it into the SMMU for the DSP as executable. It's for code. Load code into DSP, basically, is what this is for. That's my understanding.
Yeah, I still don't get it, but it's fine.
Okay. Yeah, executable and the SMMU page tables.
Okay, I have no idea what that could possibly mean. No, that's okay.
Okay,
Don't worry about it.
I'll look into it more. I'll make a note. And also, I mean, this IOPT page table mapping batching thing, that's something we should just do it. And
But skip 0, that's a really odd one, because there is already a flag to 0 out, but in one of the code paths that's ignored. So I guess that's where they added that flag. So maybe if we just follow the zeroing out flag, we don't need the skip zeroing flag.
are you saying there's a bug or something? I'm not sure.
Maybe some inconsistencies.
Okay, I'll look into it also. I think the things we just talked about, right? The OPPs and event timers, I think these are just features we're working on already. So those are kind of short-term or in-progress features. I guess event timers are not in progress, but I think we need to do that if we want to have some performance. And then the long-term projects is just, I just picked out some things I think are kind of long-term, which is the bus scaling, which seems like a big project. Also this voltage corner stuff, I think we have to do something there, and no one's really figured anything out. The IPA driver, the team that works on that has told me they want to upstream it, and they don't know how. So I need to help them, or I need to have someone help me help them figure out what to do with their code. And then this battery stuff, I think, is a big project that we need that no one's really working on. The clock stuff, that's blocked on a lot of other stuff, and I know what to do there, but it's going to take me a while to do it myself. And then the remote process stuff, I think, is a big project too. That's all the pill and all the other remote processor loading. That's a lot of stuff to do. That's all I got. So if you have any questions, you can ask me now or later. There's the microphone here too, if you want this one. Okay, thank you.